values for the mean, plus or minus 1 standard deviation, 2 plus or minus 2 standard deviations, 3 plus or minus 3 standard deviations. So I'm going to draw a normal curve to answer the question. All right, so draw a normal curve, and the mean and the median are equal in a normal curve. The mean lies at the line of symmetry. So in this particular question, we are told that the mean, or the lifespan of a dog, is normally distributed with a mean of 12.5 raw score. The mean of 12.5 and a standard deviation of 2. So if the mean is 12.5 and standard deviation is 2, a dog that is 1 standard deviation above the mean is going to be 12.5 plus 2. Therefore, if a dog is 14 years, if a dog is 14 years or 14.5 years, then that dog is 1 standard deviation above the mean. If a dog is 16.5 years, 2 standard deviations above the mean. So I want us to know how to use empirical rule in real life. It's very, very important. It's one of the properties of normal distribution, and you can't overlook this. So if a dog is 16.5 years, the dog is 2 standard deviations above the mean. If a dog is 18.5 years, then that dog is 3 standard deviations above the mean. So, okay. If a dog is 10.5 years, in other words, the mean minus 2, then that dog is 1 standard deviation below the mean. Is 10.5. If a dog is 8.5 years, 2 standard deviations below the mean. If a dog is 6.5 years, 3 standard deviations below the mean. Okay, so let me just draw them in standard deviations then. So I'm going to draw. The one I'm drawing with standard deviations and the mean is 0. So when the mean is 0, that is the mean of the data. And I will apply z-score there too. When it is 1 standard deviation above the mean, then it is to 14.5. 2 standard deviations above the mean, it's 16.5. 3 standard deviations above the mean, 18.5. If a dog is 1 standard deviation below the mean, it is 10.5. -1. Below. Anytime you say below the mean, it's negative. 2 standard deviations below the mean is 8.5. Remember, standard deviation is 2, so it means subtract. 3 standard deviations below the mean it means the dog is 6.5 years. Okay. When you draw a normal curve in standard deviations, it's called a standard normal. So this normal curve is called a standard normal. This is a standard normal curve. Why? Because you use the standardized scores. Well, the normal curve on the right-hand side is an ordinary normal curve. This is just a normal curve. A normal curve. Therefore, be careful from now on. You could be told that a normal curve has a mean of 20. That is just a normal curve. But if you're told to convert that normal curve to standard normal curve, it means find the z-score, standardize each of them. All right. And you can standardize using your Z chart, which I put in the normal standard. I put the Z chart in Blackboard this morning. Okay. Okay. So, and by the way, how did we actually arrive here? So, by the way, the important thing is that I can now say, according to empirical rule, 68% of the data, 68% of all dogs lie within one standard deviation, plus or minus one standard deviation. Another way of saying a dog weighing 10.5 years to 14.5 years lie within one standard deviation. Therefore, the percentage, the probability, that is the empirical rule is talking about probability. The probability that a dog is within plus or minus one standard deviation is 68%. The probability that a dog is within two standard deviations, within in statistics always means plus or minus. So if a dog is within two standard deviations of the mean, then the dog lies within 95%. The probability is 95%. The probability that a dog lies within two standard deviations is 95%. That's what empirical rule says. The probability that a dog lies within three standard deviations is from 8.5 years to 18.5 years. Okay, well, let's try and standardize it. And by the way, now we talked about empirical rule, so we can use empirical rule. What if we are told to use a calculator? Let's use a calculator and emphasize empirical rule. Let's actually use a calculator right now. So I am going to use my calculator to see if empirical rule is correct. Is it true that a dog lying between, or a dog uh, that has age between 10.5 and 14.5 lies in the 68% probability? Is it true? By the way, let me write an argument. I got to write this argument because it's very important. So I am going to, let me hide this first now. And I am going to clear the normal curve on the right hand side. I'm going to clear that. That way I can have normal curve on the right hand side. I'm going to clean it. Okay, so I'm cleaning this normal curve on the right hand side so that I can write the formula for using my calculator to calculate area under the normal curve according to empirical rule. So we want to verify empirical rule. So anytime I want to use my calculator, I have to write this argument: normal cumulative density function. Normal cumulative density function. This is the first time we are doing this. We are using it to emphasize the empirical rule. You might want to pay attention. I want to find the raw score first. The area between 10.5, one standard deviation below the mean, and one standard deviation above the mean, 14.5. And the mean of the data is 12.5. And the standard deviation of the data is 2. So I'm going to tell my calculator, can you use raw score to find the area, emphasize that the empirical rule is correct. So this is what I'm going to tell my calculator. Then I pull my calculator up. And then everybody listen. Whenever you are looking for normal cumulative density function, you're looking for area under the normal curve. And area under the normal curve is second distribution. Second verse, second distribution. And normal cumulative density function is area under the normal curve. Number 2, area under the normal curve. You must remember what I'm saying now. Very important. Well, I'm using a raw score. One standard deviation below the mean is 10.5. The good thing about your calculator is that it doesn't matter if you're using a raw score or using a standardized score, it can still do it. That's why you must know how to use your calculator. So the lower bound is 10.5, one standard deviation below the mean. The upper bound is 14.5, one standard deviation above the mean. The mean of this data, raw score, is 12.5. That's the lifespan of a dog, the mean of a lifespan of a dog. And the standard deviation of the lifespan of a dog is 2 years. 2 years, because I'm using raw score. So I'm going to calculate, is it going to be approximately 68%? According to my calculator, according to empirical rule. So my calculator is asking me, is this what you want me to calculate? Yes. I want me to calculate the area under the normal curve within these raw scores. Yes. Therefore, my calculator actually agrees with empirical rule. It says that approximately 68.27% of data lie within plus or minus one standard deviation. Within and plus or minus are the same. So when you say within and say plus or minus, like I just said, it's a tautology. But anyway, my calculator agrees with empirical rule, 68.28% lie within one standard deviation. So my calculator agrees with empirical rule. I must know how to use my calculator to calculate questions on empirical rule, because sometimes it gets bad. It gets more difficult when I have decimal points there. Okay. So actually, I use the empirical rule and I just use my calculator. What if I'm told to calculate the area under the normal curve within plus or minus 2 standard deviations? I know that plus or minus 2 standard deviations is going to be 8.5. So plus 8.5 on the left-hand side, a dog that is 8.5 years. On the right-hand side, it will be a dog that is 16.5 years. So we want to verify, is the area between 8.5 and 16.5 the same as 95%? Because remember, empirical rule says 68, 90, 95, and 99.7. So I'm verifying the second one, area between 2 standard deviations. So I'm going to pull my calculator up again. And by the way, let me write the argument. So normal cumulative density function, the lower bound is 8.5. The upper bound is 16.5 this time, because I'm talking about 2 standard deviation. The mean is 12.5, and the standard deviation is 2. I'm going to tell my calculator what I found. So I'm trying to verify that within 2 standard deviation is 95%. So I'm going to second verse, that's second distribution. Number 2, lower bound is 8.5. Upper bound is 16.5 plus or minus 2 standard deviations. The mean is 12.5, standard deviation is 2, and I'm going to calculate. It's asking me, is that what you want to type in? Yes. So I hit enter. Behold, the area between plus or minus 2 standard deviations is 95.45 approximately. By the way, my calculator is more accurate. The calculator is more accurate, so it actually has all the decimal points. So area between plus or minus 2 standard deviation is 95.45. 5. Therefore, my calculator actually agrees with empirical rule. All right. Okay. So what I'm going to do now is pull my chart, Z chart. I want to verify that too. By the way, how do we read the Z chart? How do we read the Z chart? The first thing we verified is that the area between plus or minus is 68. The second thing we verified is area between plus or minus 2 is 95%. Let's verify that reading the chart. So I'm going to pull my chart. This chart is in Blackboard. I put it in this morning. Okay, so I'm looking for the Z chart. Remember that the first thing is to find the area between plus or minus 1 standard deviation. So the first thing I am going to do is go to, by the way, I will write Z upper bound. The upper bound is 1, the greater one. Z upper bound, Z1. Z1 minus, minus Z negative 1. Z negative 1. Okay. All right. So what I'm going to do now is Z negative 1. Okay, I'm going to do this on another. So Z1 minus Z negative 1, I'm going to make this smaller. That way I can. So what is Z1? So how do I find it? On the chart, I will look for 1. On the chart, I will look for, let me look for Z negative 1 first. See, the Z negative 1 is 0.1587. So I am going to write this again, Z1 point, and this Z negative 1. So the negative 1 is a smaller number, 0.1587. I'm going to check that again. All right. Then the upper bound is Z1. So I am going to pull my chart again and looking for Z1. I'm looking for Z1, and Z1 right here is 0.8413, Z1 0.8413. So this place is 0.8413, 0.8413, and I am going to subtract. I'm looking for area between plus or minus 1 standard deviation. So that's why I found the Z of 1, I found the Z of negative 1, and I'll subtract because I'm looking for area between. All right. So I'm going to say 3 minus 1 is 2 right here. And this is 1 here. Borrow 1 is 11 minus 8 is 3. And then I have 3 remaining here. Borrow 1 is 13. 13 minus 5 is approximately 8. And then I have 7 here minus 1 is 6. Therefore, my calculator, actually the Z chart, also agrees that 68% of data lie within 1 standard deviation. I want you to notice that Z chart is a little bit less than the calculator. The empirical rule says approximately 68. The calculator says 68.44. Then the Z chart says 68. It doesn't really matter. If you round it up to 2 decimal places, they're all going to be 68. Therefore, Z chart agrees with empirical rule. My calculator agrees with empirical rule. And so empirical rule says 68. So you need to know, by the way, how to use your calculator to calculate area under the normal curve, you need to know how to use the z-chart to calculate the area under the normal curve. You also need to know how to use empirical rule. Sometimes, let's go down so you can see that sometimes the decimal point will make it difficult for you to use empirical rule and be correct. So if there are decimal points there, sometimes it makes it difficult for you to be accurate. Therefore, knowing how to use a calculator will be your best bet. Okay, well, this is another real world problem. This real world problem talks about light bulb. Whatever you're doing in this life, whatever you plan to do, you will be using z-score. You will be using z-score. Z-score is used in everything. Okay, and so let me try and answer this question with ordinary z-score. Forgive my crooked z-score. The mean, the lifespan of a certain type of light bulb is normally distributed. That's the most important thing, because empirical rule is used with normal distribution, with a mean of 5,000. So this mean here is 5,000. Therefore, this is not a standard normal curve, because I'm drawing it with raw score. So it's not a standard normal curve. And the standard deviation is 150. So one standard deviation above the mean will be 5,150. Two standard deviations above the mean will be 5,300. And three standard deviations above the mean will be 5,450. Okay, so this is one standard deviation above the mean. Two standard deviations above the mean. Three standard deviations above the mean. All right, what is one standard deviation below the mean? 5,000 minus 150. So that is 4,850. What is two standard deviations above the mean? 4,700. What is three standard deviations below? I mean, I'm talking about below the mean. If it's just less than 5,000, it's below. It is 4,650. Okay. I could be told to find the area between. So now I know that from here to here is 68%. From here to here is 95%. From here to here is 99.7. So I already know that from empirical rule. But suppose I don't know. Suppose it's confusing. I'll put it in my calculator quickly and find the area between. If I standardize them, then I'm going to draw. And then if I standardize the the mean, I have 0. By the way, let's standardize the mean. So mean, z-score, remember we talked about z-score is value minus mean, value minus mean over standard deviation. So we want to just make sure we know that if I standardize the mean is going to be 0. So let's make sure we know that. So trying to standardize the mean right now, that's what I'm trying to do in this particular question. So what is the value? If I'm standardizing the mean, it is mean 5,000 minus mean 5,000 over standard deviation, which is 150, which means there's a 0 in the numerator of 150. That is why I put a 0 here, because if you standardize the mean, you get a 0. What if I standardize one standard deviation above the mean? That is 5,150. So z-score for that will be value 5,150 minus the mean 5,000 over standard deviation 150. See, 5,150 minus 5,000 is 150. 150 divided by 150 is 1. So that is why we know that this is 1. We keep standardizing. We have 1, 2, 3. On the right-hand side of the mean. On the left-hand side of the mean, don't forget it is negative because it says below the mean. So you know that if you standardize, you have standard normal distribution. Standard normal distribution. Okay, so let's go to question number 3. And I want to explain to you why you need to know how to use your calculator. You need to know how to use your calculator because all questions on empirical rule don't come easy like that. So knowing how to use your calculator will be your best bet. If it looks complicated, you put it in your calculator. But if you don't know how to use your calculator, that is the problem. So from now on, in every test, there will be a question on empirical rule that can be, it might not just look good to use just empirical rule. So knowing how to use your calculator, knowing how to read the chart will be very good. Okay, so first of all, I am going to find the area between the mean is when you standardize the mean, you get a 0. So our first thing is to draw a normal curve. Well, this chart, they already standardized for me. So I don't even know the raw score. That's the problem. They already standardized for me. I really don't use empirical rule here because I have 0.28. Using empirical rule in this question will take you a whole lot of time. It may take you a lot of time that you actually miss the test. So sometimes a question on empirical rule requires you to use your calculator. That's what I'm trying to emphasize. So, but if you know how to use your calculator, you just say, you're looking for area under the normal curve between 0 and 1. You say normal cumulative density function. I'm saying that for a long time, for a lot of times today, because this is the first time we are doing it, and I'm repeating it to make sure you know it. You must know how to do this. So, lower bound, smaller number. Upper bound, the bigger number. The mean of the data, 0. Standard deviation is 1. Because this is standardized, so the mean is 0, standard deviation is 1. And I don't even know the original data. And so using empirical rule will be difficult. That's why I need to know. So I'm going to use my calculator this time. So I am going to use my calculator. I don't have the raw data. If I'm told to use empirical rule, it's not going to be an easy task. So I'm going to use my calculator. So where do I find normal CDF? Second verse, number 2, this is normal cumulative density function. The first one is asking you what is the lower number. What in this particular question, it is standardized. So the mean is the lower number. The upper number is 1.25. The mean of a standard normal is 0. The standard deviation of a standard normal is 1. Okay, so now you calculate. So I'm going to calculate the area between, it's asking me, is that what you want to do? Yes. So the area between these two numbers is 39.43%. That is 39.43%. So the area, what if I use the chart? Let me use the chart. I'm going to use the chart to find that area also. So I'm going to pull up the chart. And the lower bound is 0. We already know that 0 is at the center. The mean divides the normal curve into 2 equal parts. So I can say Z upper bound 1.28 equal to and the z lower bound, z0, is equal to, I'm subtracting, by the way. So I'm going to get my chart and read 1.28. So I'm getting my chart. So now I'm looking for 1.28. This is 1.2 right here. So 1.28, by the way, let me start from the beginning. 1.20, 1.21, 1.23, I mean 1.20, 1, 2, 3, 4. So I have to be going to almost the extreme. And so 1.28 is right here. 1.28 is right here. Okay, so what is it? 0.8997. So 0.8997, 0.8997. I already know that Z0 is 0.5. Let's check it out. Normal curve divide, the mean divides the normal curve into two equal parts, but let's check that out. So Z0, what is Z0? I'm asking my calculator, what is Z0? This is Z0 right here is 0.55. Why? Because the area under the normal curve is 1, and the mean is at the center of the normal curve. Therefore, the mean divides the curve into two equal parts. So I already know the lower bound, the upper bound is 0. It means 0.5. So I don't. So I put 0.5000 here, and I'm going to find the difference. When I find the difference, I have 3 here, 0.3990 approximately, and that's my answer using the chart. According to 39.9%, 39.9% according to the chart. Remember, my calculator is more accurate. So this is the area under the curve using my calculator. This is the area under the chart using my calculator. I don't even want to use empirical rule because I don't want to waste time looking for 0.28. That's one thing I'm trying to tell you. So very soon, empirical rule will not, the question might not allow you to use empirical rule. Therefore, you are left with your charts and your calculator. The most important thing is that if your answer is 39.43 approximately, your answer is correct. I hope everybody understands this. This is very, very important. Okay, so I'm going to answer another question. Let's do number 4. Actually, we're going to do number 5 because let's do number 5 for a reason. So actually, some questions can be standardized, and they will ask me, which means I don't know the raw score, the raw data, and they ask me to use empirical rule. But if I'm told to use empirical rule and I see a lot of decimal points there, well, guess what? I will quickly use my calculator, but I have to know how to use my calculator. This one right here is very important. Sometimes you are told to find area to the right of Z. So let's draw this picture. I'm going to draw the picture, area to the right of Z equal to 2.4. So I have to first of all place 2.4 correctly. 2.4 is positive. The mean is 0. 2.4 is positive, so it's on the right-hand side of the mean. 2.4, area to the right of 2.4. Okay? And then I don't know the upper bound, but the normal curve is going to positive infinity. Therefore, infinity is at the right. But my calculator does not understand infinity. Therefore, I should put 1.1 e to the power 99 here. My calculator does not understand infinity. That means I need to put 1 e to the power 99. Remember, the question can always say find area to the right or area to the left. If it is area to the left, then it is negative 1 e to the power 99. Okay, so what I'm going to do now is pull my calculator up. By the way, what kind of arguments do I have? So this is the argument I'm going to put in. Normal cumulative density function. Lower bound is 2.4 because 2.4 is smaller than positive infinity. Upper bound is positive infinity. The mean of a standard normal is 0. Standard deviation is 1 because we are counting in standard deviations. So I'm going to pull my calculator up and find the area between 2.4 and positive infinity. So I'm going to clear. And then where do I go? Second distribution again. I'm looking for area under the normal curve. Number 2 is area under the normal curve. And the question is asking me to find area from 2.4 is smaller than positive infinity. So lower bound is 2.4. Upper bound is infinity. How do I type infinity? How do I type positive infinity in my calculator? Put in 1. And how do I find E? E is exponent. So second comma, that E in second comma, double E is the infinity. Power 99. I'm going to do it again. Second comma, that's where you get the E. The mean is 0. Standard deviation is 1. Calculate. Therefore, the area under the normal curve from 2.4 to positive infinity is approximately, I'm going to put it in percent, approximately 0.82%. 0.82% area to the right. Then if you're told to find area to the left, this is what you're going to do. The same thing. I'm going to clean this one. And then what if I'm told to find area to the left? One thing is, at this point now, empirical rule is out of the, you rule empirical rule out. Because see, this is decimal point, and you can't try empirical rule right here. You either use your calculator or you read the chart. Okay, it's easier to use your calculator though. So I'm going to draw a normal curve. I'm told to find the area to the left. Careful. Area to the left means from this number to the left. So this number is negative, therefore it's on the left-hand side of normal curve. On the left-hand side of normal curve. That's 0.46. And I'm told to find the area to the left. And I don't know where the left stops, so it is negative infinity. Negative 1 e to the power 99. So what do you type in your calculator? Write the argument right here. Normal CDF. What is the lower bound? Negative infinity is smaller. So negative infinity. The number negative 0.46. The mean is 0. Standard deviation is 1. Okay, let's calculate. All you have to do is put it in your calculator. And that is the story. It's not a big deal if you know how to use your calculator. So I'm going to clear everything. Go to second verse and do number 2. I know why I'm repeating it. I'm recording this. So you might want to go back and watch this video again. How do I tell my calculator? Type in negative infinity. Type in negative first. 1. How do we put in that E? Second, comma, 99. So you have told your calculator that you're looking for area from negative infinity, which is to the number, the upper number is negative 0.46, negative 0.46. All right. And I'm told to find the area between negative infinity and that negative 0.46. The mean of a standard normal is 0. Standard deviation is 1. Calculate. And it's asking me, is that what you want? Yeah, that's what I want. So that area from negative 0.46 to negative infinity is 32.28%. 32.28% using my calculator. Even if I use my chart, I'll get the something. So you know how to, by now, you should know how to use your chart. You should also know how to use your calculator to calculate the area under the normal curve. Let me say this again. The chart, the Z chart is in the blackboard. This worksheet is also in blackboard. So I want us to use this worksheet to practice how to calculate the area using empirical rule, area under the normal curve, using empirical rule, using the calculator, and using the charts. Everybody needs to know how to do this. Everybody needs to know how to do this. All right. I think I wouldn't go further than this because this is a whole, it's new to us. That way, we want to make sure we get it. If you can do the first page of this worksheet, even if you don't want to do the first page, that's just fine. I want you to see number 9 is still probabilities. So I want you to know they're talking about probabilities. The same thing. All you have to do is draw a normal curve. Draw a normal curve. The number at the left is a smaller number, negative 1.25. The number at the right is the bigger number, and they're telling you to find the area. We already know how to do this. So what you do is normal cumulative density function. I know why I'm repeating this, because it's important that you know how to do this. What is the lower number? Negative 1.25. What is the upper number? The mean. And actually, you can let me put everything in. Okay. And then the mean is 0. The standard deviation is 1. Then you calculate. Okay. So your calculator will give you the accurate number. I want you to know that this is the same thing as area to the right. So this is also the same thing as area to the right, greater than. This is the same as area to the left. So there's no big thing here. This is area between. Well, we have to be careful because this is area to the right and this is area to the left. Next class, I want to make sure that I tell you that the normal curve is symmetrical. So if the number here is the same as the number here, then area is never negative. Area to the right is the same as area to the left. If the z-score is, the absolute number of the z-score is the same. Okay. What you have to study today is to make sure you can calculate the area under the normal curve with empirical rule. You can calculate the area under the normal curve with your calculator and calculate area under the normal curve with the z-chart. You can read it up. You can watch the author's video. You can come back and watch this video. It's very important that you know it. Okay, I'm going to stop here because really we are reviewing. But we are reviewing. I want to let you know that empirical rule, knowing the empirical rule is not enough. I want you to also know how to use your calculator to calculate whatever the empirical rule is asking you.